Have you ever stopped to wonder if there's a limit to how smart we can actually get? I mean, we've built supercomputers, we've sent robots to Mars, but what if our own brains, the things doing all that thinking, have already hit a hard biological ceiling? We're going to dive into why our own biology might be the biggest thing stopping us from getting any smarter. So here's the big question, right? If being smart is such a massive evolutionary advantage, why did we stop? Why aren't our brains getting bigger and more powerful with every single generation? Well, the answer isn't that evolution just gave up. It's that it ran smack into a series of physical walls it just couldn't get around. And we're going to break down the 5 key reasons our intelligence just plateaued. We'll start with the surprising heat problem, then look at our brain's surprisingly slow processing speed, why being bigger isn't actually better, the moment evolution really did hit a wall, and finally, the really clever software cheat our brain uses to get by. All right, first up, let's talk about the single biggest thing holding your intelligence back: heat. It turns out thinking hard is a really dangerous business, and your brain's greatest enemy is the waste heat it creates just by being on. Okay, picture a high-performance computer in a server room. It needs these massive, screaming fans just to keep from literally melting down. Well, your brain is just as powerful, but it's trapped in a sealed, insulated box, your skull, with 0 fans. It has a massive fundamental cooling problem. And just how intense is this problem? Get this. Your brain is a tiny 2% of your body's mass, but it devours a staggering 20% of all your energy. It is an incredibly power-hungry organ, and all of that energy use generates a ton of waste heat. In fact, your brain is constantly running at about 20 watts. That's like having a small space heater switched on inside your head 24 hours a day, 7 days a week. And the only cooling system you have is your own blood, which has to rush in, soak up that heat, and carry it away before things go very, very wrong. So what happens if it gets too hot? We're not made of silicon like a computer chip, we're made of proteins. And when proteins get too hot, they do something called denaturation. They unravel, they lose their shape. The best example is just frying an egg. The clear liquid part turns solid and white. That's denaturation, and it's exactly what would happen to your brain's proteins if they overheat it. And this is the critical point. Your brain operates at 37 degrees Celsius. Permanent damage starts at just 42 degrees. That is a 5-degree safety margin. 5 degrees! We are constantly running right up against the red line, which means evolution literally can't turn up the power without cooking us from the inside out. Okay, so let's move on to our second bottleneck, because it just builds from here: speed. Even if we could solve the heat problem, we're stuck in biology's slow lane. There's a fundamental reason machines will always think faster than we do. Signals in a computer travel near the speed of light. It's almost instantaneous. But our brain signals, they're basically chemical waves. And the parts of your brain that are doing the actual thinking, those signals are chugging along at about 10 to 30 meters per second, basically the speed of a bicycle. We're in a race against physics, and we've brought a bike to a fighter jet fight. And this has a really weird consequence. Because our internal wiring is so ridiculously slow, it actually takes time for a signal to get from your eyes to your consciousness. What that means is you are literally never seeing the world in real time. You're always watching a slightly delayed broadcast of reality. So this brings us to the next obvious question, right? If we can't be faster, why not just be bigger? Why don't we have brains the size of a peach ball? Well, it turns out that making the brain bigger creates its own massive, massive problem. It's called the wiring problem. See, as you add more neurons, the number of connections you need between them just grows exponentially. The sheer volume of wires becomes completely unmanageable. And even worse, because our signals are moving at bicycle speed, a bigger brain would mean it would take forever for one side to talk to the other. It would become agonizingly slow and inefficient. So evolution figured out that being compact is actually way more important than just being huge. That's why our brain is so wrinkly and folded up on itself. It's not a flaw, it's a brilliant design feature to pack as much processing power as possible into the smallest space, keeping those all-important wire lengths as short as they can possibly be. And we have absolute proof that this isn't just a theory. If we look at our own history, it is crystal clear that about 200,000 years ago, our brain's incredible growth spurt came to a screeching halt. The 2 million year party was officially over. Just look at this timeline. For nearly 2 million years, the hominid brain was on this explosive growth path, tripling in size. It was one of the fastest evolutionary developments we know of. But then, right around the time modern humans showed up, it just stopped. And in the last 10,000 years, it's even shrunk a little. So why? Why did it stop? It stopped because evolution ran into 3 impenetrable walls all at the same time. The metabolic wall, we just couldn't find and eat enough calories to power an even bigger brain. The thermal wall, like we saw, we couldn't cool it. And finally, the obstetric wall. A larger skull simply couldn't fit through the human pelvis during childbirth. Evolution was completely and totally boxed. This all leads to our final and maybe the most fascinating point of all. If our biological hardware is completely maxed out, then how have we managed to become so much more capable over the last few centuries? Well, the answer isn't in the hardware, it's in the software. You might have heard of the Flynn effect, this observation that IQ scores rose dramatically all through the 20th century. This wasn't because our brains were evolving to be better. The hardware didn't change one bit. What changed was our software. Better nutrition, better education, new ways of thinking. We just learned to use the hardware we already had much more effectively. And that brings us to a really sobering conclusion. Biologically speaking, we've probably gone as far as we can go. Our brains are an absolute marvel of engineering, but they are a machine that has hit its absolute physical limits on heat, on energy consumption, and on size. So how does our very limited hardware cope with an infinitely complex world? Well, it doesn't even try to process everything. That would be completely impossible. Instead, as this quote puts it, we survive by cheating. Our consciousness is a piece of software that is brilliantly designed to ignore almost everything and just focus on the tiny, tiny fraction of reality that actually matters for our survival. Which leaves us with one final, pretty provocative thought. We know the hardware is finished, it can't get any better, so the entire future of human intelligence, our ability to solve the massive challenges that are ahead of us, now rests entirely on one question. What is the future of our software?